Okay, today we're going to start with notes 1A of using patterns of integer exponents. We will end up also talking about negative exponents and zero exponents. Okay, first I want everybody to start by looking at the patterns that you guys see. There's a 5 to the 4th, 5 to the 3rd, 5 to the 2nd, 5 to the 1st, 5 to the 0, 5 to the negative 1st. And I want you guys to look at how the answers are filled in. 5 to the 4th is 625, 5 to the 3rd is 125, 5 squared is 25, 5 to the 1st is just 5. So what I want you guys to notice is it looks like as the exponent decreases in value as it goes 4, 3, 2, 1, the value of the power is divided by 5. So now I want you to think about what would be 5 to the 0. If each one of these is divided by 5, what would be 5 divided by 5? I hope you're thinking 1, because that's correct. If we now took 1 and divided it by 5, it would look like this. That's supposed to be a 5. And now if we divided by 5 again, I'm not sure how many of you guys remember how to divide a fraction by a whole number, but if you remember keep, change, flip, you would actually be multiplying 1/5 times 1/5 because the whole number 5 would flip to the bottom. So 5 to the negative 2nd would actually be 1/25. Okay, now let's try the 4s. 4 to the 4th, 256. 4 to the 3rd, 64. 4 squared is 16. 4 to the 1st is 4. So 4 to the 0 power. Think about if this number was divided by 4, what would you get? I hope you got 1. Now, divide 1 by 4 to get 4 to the negative 1st power, and I hope you said negative 1/4 in your head. The next one would be 1/16, because again, if you multiplied by its reciprocal, 1/4 times 1/4 is 1/16. Okay, what I want you guys to start noticing is a pattern. Pause the video, and if you can, try going ahead and filling in these last 3 boxes on the table on your own, and then press play to continue to see if you got it right. Okay, 3 to the 0 is 1. 3 to the negative 1 is 1/3, and 3 to the negative 2 is 1/9. I'm writing outside the boxes, but I'll erase those and make those go away. So now I want you guys to start thinking about what pattern did you see out of just the powers of 5s? So if we were just looking at the 5 to the 4th, 5 cubed, 5 squared, 5 to the 1st, 5 to the 0, 5 to the negative 1, and 5 to the negative 2, what pattern do you see? What I want you guys to notice is exactly what I had said earlier. As the exponents decrease by 1, sorry for the handwriting. As the exponents decrease by 1, the value of the power is divided by 5. I'll erase this in a minute. So you guys should be writing a lot smaller and it should fit for you. Is divided by 5. Okay, so what pattern do you see in the powers of 4? I hope what you guys see is as the exponents decrease by 1, the value of the power this time is not divided by 5. If we're not looking at the 5s this time, now we're looking at the 4s instead. Each one is divided by 4. Okay, so knowing that, you should predict what the next question is. What pattern do you see in the powers of 3? So this time if you look at the powers and the patterns of 3, you will not see it divided by 5 or 4, but now you're going to see that the power is divided by 3. Okay, take a minute and make sure you guys are writing each one of those. I only wrote it once, but you guys should write it 3 times, each under the different question. Okay, for the next part down, you can see that it wants us to complete the table for the values, which we already did. So we did that earlier. So that is all completed, I hope. I hope above you kind of filled it in as we did. So let's go back to the next question. What conjectures can you make about a number that has an exponent of 0? A conjecture is just a rule, basically. So if it says, what conjecture can you make about a number that has an exponent of 0, I want you to look at the table that has all of your 0 values in it and decide that 5 to the 0 equals something, 4 to the 0 equals something, 3 to the 0 equals something, and I basically want you to come up with a rule or conjecture about what's been happening with each of those. And I hope you realize that since they all are equal to 1, we can say that any number to the 0 power is going to be equal to 1. So I'm just going to call it A, because when you write a conjecture, it's like a formula. You're basically writing a rule. So A could be any number. So we're going to say A to the 0, and A could be any number, is going to be equal to 1. This is your conjecture. You can erase all this other stuff if you want, but any number, which is our A, any number to the 0 is going to always be equal to 1. All right, let's take a look now at what conjectures you could make about a number that has a negative exponent. So up here we did an exponent of 0. What did you notice about your exponents that were negative? So if you notice that 5 to the negative 1 was equal to 1/5, 4 to the negative 1 was equal to 1/4, 3 to the negative 1 was equal to 1/3. What kind of a rule? Using A. Let's go back to using A, because that would be more like our conjecture. What could we say about A to the negative, and it doesn't matter, so we're just going to call it N. N could be any number, A could be any number. Anytime you have A to the negative N, that does not look like a good N. That is an N. A to the negative N, that is going to always be equal to 1 over whatever that number was to whatever that N was, but positive. I'm going to give you a quick example of why this is our conjecture. Let's say it was 5 to the negative 3rd. That is actually going to be equal to 1/125th. And the reason is because it's the same thing as if it was 1 over 5 to the positive 3rd. That would be 1/25th. So basically, anytime you see a negative exponent, I want you to flip it to the bottom, make it positive now, and go ahead and do the math. What is 5 times 5 times 5? It's 125. Okay, for the last part, I really want you to try it on your own. 6 to the negative 2, and then 152 to the 0. If you absolutely still don't get it after these notes, you can continue watching the video and it will talk you through it, but I would like for everyone's goal to try to be to pause the video and try the your turns on your own. Alright, either if you turned the video back on just now, or maybe you weren't ready to pause it and try it on your own, I will go ahead and work out the bottom two for anyone who's just ready to check to make sure they did it on their own correctly, or to maybe you didn't get it. 6 to the negative 2nd power. That would be the same as 1 over 6 to the positive squared, to the positive 2. And 6 to the positive 2 is 6 times 6, so our final answer is 1/36. Alright, 152 to the 0 would be equal to 1. Remember, anything to the 0 power is 1.